Why are there not more people talking about the wonders of our universe? Look up at the night sky. What do you see? Tiny pinpricks of light scattered across a vast darkness. Each of those dots is a star, much like our sun. And around many of those stars orbit planets, moons, and countless other celestial bodies. This is our universe, and it's far more incredible than we could ever imagine. In this video, we will discuss some mind-blowing facts about the universe. The universe is everything, all of space and time, all forms of matter and energy. It's every galaxy, every star, every planet, and every atom. Our journey into the cosmos began millennia ago when our ancestors first gazed at the stars. Today, we have powerful telescopes, space probes, and sophisticated theories. These tools allow us to peer deeper into space and further back in time than ever before. Yet the more we learn, the more we realize how much we don't know. So fasten your seatbelts. We're about to embark on a cosmic adventure that will challenge your understanding of reality itself. Mind-boggling numbers. The scale of the cosmos. Let's start with something simple. How big is the universe? The honest answer is, we don't know. The observable universe, the part we can see, is about 93 billion light-years across. That's 93 billion times 9.46 trillion kilometers. And remember, that's just the part we can see. The actual universe could be much, much larger. Now, let's talk galaxies. How many do you think there are? 1,000? 1,000,000? Try hundreds of billions. The Hubble Space Telescope's deep field image captured thousands of galaxies in a patch of sky no bigger than a grain of sand held at arm's length. Extrapolate that across the entire sky, and you get a number that's truly staggering. And each of those galaxies contains billions of stars. But stars and galaxies are just the beginning. There are also planets, moons, asteroids, comets, and countless other objects. Our Milky Way galaxy alone is estimated to contain between 100 to 400 billion stars. The scale of the cosmos is truly beyond human comprehension. It's a humbling reminder of our place in the grand scheme of things. The invisible majority, dark matter, and dark energy. Imagine you're watching a puppet show. You can see the puppets moving, but you can't see the strings or the puppeteer. That's a bit like our situation with dark matter and dark energy. We can see their effects, but we can't directly observe them. They're the invisible majority of our universe, making up about 95% of its content. Dark matter holds galaxies together with its gravity. It doesn't interact with light, making it invisible, but its gravity affects everything around it. Dark energy is even more mysterious. It pushes the universe to expand faster and faster. Together, they make up about 95% of the universe. Cosmic oddities, black holes, neutron stars, and cosmic rays. First up, black holes. These are regions of space where gravity is so strong that nothing, not even light, can escape. They're formed when massive stars collapse at the end of their lives. At the center of a black hole is a singularity, a point of infinite density where the laws of physics break down. Black holes come in different sizes. Stellar black holes are a few times more massive than our sun. Supermassive black holes, found at the centers of galaxies, can be millions or billions of times more massive. Our own Milky Way has a supermassive black hole at its center, called Sagittarius A. In 2019, we got our first image of a black hole, thanks to the Event Horizon Telescope. Next, let's talk about neutron stars. These are the collapsed cores of massive stars. They're incredibly dense. A teaspoon of neutron star material would weigh billions of tons on Earth. Neutron stars spin incredibly fast, some rotating hundreds of times per second. Finally, we have cosmic rays. These are high-energy particles that zip through space at nearly the speed of light. Section 5. Stellar nurseries. The birth of stars. Stars are the building blocks of the universe. They produce the heavy elements that make up planets, and ultimately, us. But how do stars form? It all starts in vast clouds of gas and dust called nebulae. These cosmic nurseries are where stars are born. Nebulae are primarily composed of hydrogen and helium, the two lightest elements. They also contain traces of heavier elements left over from previous generations of stars. These clouds can be enormous, spanning hundreds of light years. The process of star formation begins when parts of a nebula start to collapse under their own gravity. As the gas and dust fall inward, they form dense clumps. These clumps continue to grow, attracting more and more material. As they collapse, they also start to spin faster, just like an ice skater pulling in their arms. As the clump gets denser and hotter, it forms a protostar. If it gathers enough mass, the temperature and pressure at its core will eventually become high enough for nuclear fusion to begin. Section 6. Stellar Evolution. From main sequence to red giants. Once a star is born, it enters the main sequence, where our Sun is now. Stars fuse hydrogen into helium, releasing energy. The length of this phase depends on the star's mass. When hydrogen runs out, the core contracts and the outer layers expand. The star becomes a red giant. Its outer layers swell, potentially engulfing nearby planets. Helium fusion begins, creating carbon and oxygen. Section 7. Explosive Endings. Supernovae and their aftermath. The fate of a star after the red giant phase depends on its mass. For massive stars, the end is dramatic. Stars at least 8 times more massive than our Sun explode in a supernova. This explosion can outshine an entire galaxy. A supernova releases immense energy in seconds. It creates elements like gold and uranium. These elements enrich the interstellar medium. Stars between 8 and 20 times the Sun's mass leave neutron stars. More massive stars collapse into black holes. Section 8. Worlds Beyond Our Own. The Hunt for Exoplanets. For centuries, we wondered if there were planets around other stars. Now, we know the answer is a resounding yes. Exoplanets, planets orbiting stars other than our Sun, are everywhere. As of 2024, we've confirmed over 5,000 exoplanets, with thousands more candidates awaiting verification. Finding exoplanets isn't easy. They're small, dark, and lost in the glare of their parent stars. But astronomers have developed clever techniques to spot them. The most successful method is the transit method. When a planet passes in front of its star, it causes a tiny dip in the star's brightness. By watching for these regular dips, we can detect planets we can't see directly. Another method is the radial velocity method. As a planet orbits, it causes its star to wobble slightly. This wobble can be detected by very precise measurements of the star's light. This method has been particularly good at finding large planets close to their stars, like hot Jupiters. The diversity of exoplanets we've found is staggering. There are planets larger than Jupiter and others smaller than Mercury. Perhaps most excitingly, we've found many planets that could potentially support life as we know it. Section 9. Are we alone? The search for extraterrestrial life. The question, are we alone in the universe, has fascinated humanity for centuries. Now, for the first time in history, we have the tools to start answering it scientifically. The search for extraterrestrial life is one of the most exciting frontiers in astronomy and biology. When we search for life beyond Earth, we start with what we know. Life as we know it requires liquid water. So we look for planets in the habitable zone of their stars, where temperatures could allow liquid water to exist on the surface. We've found many such planets, including some that are similar in size to Earth. But having liquid water doesn't guarantee life. We also look for biosignatures, chemical signs of life in a planet's atmosphere. These could include gases like oxygen or methane, in combinations that are hard to explain without life. Future telescopes, like the James Webb Space Telescope, will be able to study the atmospheres of some exoplanets. We're not just looking for microscopic life. We're also searching for signs of intelligent life. The search for extraterrestrial intelligence, SETI, uses radio telescopes to listen for artificial signals from space. So far, we haven't heard anything conclusive, but the search continues. Section 10. Pushing the Boundaries. Recent space missions and discoveries. The past few years have been incredibly exciting for space exploration. We've sent probes to the outer reaches of our solar system, landed rovers on Mars, and even touched the Sun. Each mission brings new discoveries and pushes the boundaries of our knowledge. One of the most ambitious recent missions is NASA's Parker Solar Probe. Launched in 2018, it's the first spacecraft to fly into the Sun's outer atmosphere, or corona. It's helping us understand how the Sun works and how it affects us here on Earth. The probe has already made several close passes of the Sun, each time getting closer than any human-made object ever has before. On Mars, NASA's Perseverance rover is searching for signs of ancient microbial life. It's exploring Jezero Crater, which scientists believe was once home to a river delta. The rover is collecting rock samples that will be returned to Earth in future missions. It also carried a small helicopter, Ingenuity, which became the first aircraft to make a powered, controlled flight on another planet. Section 11. The Final Frontier. What lies ahead in space exploration? As we look to the future, the possibilities for space exploration seem endless. We're on the cusp of a new era of human spaceflight. Several countries and private companies are planning missions to the moon. Let's see what is coming next in our space journey. Thanks for watching. Please like, share, and subscribe to our channel. We will see you in the next video.